There we go. All right. So today we're going to be talking about the properties of logarithms. There's the product property, the quotient property, and the power property. And we're going to use this to combine logarithms into one log. So we're going to take multiple logarithmic expressions and condense them down. And then we also want to use something called the change of base formula to change the base of a log. So here we go. Grab your notes. Let's get started. Oh, weird. Why is it looking at me? That's where my camera went. Let me see if I can fix that. There we go. Now it's looking at what I want it to. And hey, my regular camera works now too. That's fun. And I'm going to focus this a bit. All right. 3.3. Ow, come on. Nope, not quite. Properties of logarithms. Okay, so 3.3 properties of logarithms. Here we go. The first property is called the product property. And so I'm just going to put out all these properties that we have. I'll show a brief example of each of them, and then we are going to show some examples of how we would evaluate a log using these and how we would combine logarithms using kind of all these properties together. So the first one, product property. So the product property says, if you have some log with a base of b of x times y, that you can split up into addition. Log b of x plus log base b of y. So if you have them multiplied, you can split them up into addition. If you have them as addition, you can combine them into multiplication. That's the way we're going to use it the most often. And they do have to be a log with the same base. So if this was log base 4 and this was log base 7, you could not combine them. But since they have the same base, we can. Kind of like with exponents, when you would have, it's actually the opposite of the way the exponents work. It's the exact opposite, which hopefully makes sense because we know that logs and exponents undo one another. They are inverses, so they work in opposite ways. So remember with exponents, if you had like 4 to the x times 4 to the 7th, that would be the same as 4 to the x plus 7. So with exponents, you can combine multiplication into addition. With logs, you can combine addition into multiplication. It's the opposite way around. So that's kind of nice. But I'm going to erase that so we don't confuse that with what's going on over here. So for example, here if we had log base 4 of 7 plus log base 4 of x, I could combine these into log base 4 of 7x. So if I was going to combine logs, I could do it like this. And this is going to help us when we come to start solving logarithmic equations in 3.4, because then if you can combine them into one log on one side and like something else on the other side or whatever, you can get rid of the log by putting a 4 underneath both sides in the base and canceling out the log base 4. But that's something we'll get to later. First, the only thing we need to know right now is the product property that says you can combine these into multiplication. All right, the second property is the quotient property. So that is log base b of x over y. So if I have things that are divided, I can turn it into subtraction, or if I have things that are subtracted, I can turn it into division when I'm condensing it. So that would be log base b of x minus log base b of y. So for example, if I have natural log of x minus natural log of 9, I can combine these and make it division and get natural log of x divided by 9. So I can condense things with subtraction. I can condense things using addition. And then the final property is called the power property. So the power property says that if we have log base b of x to some exponent p, that is the same thing as bringing the exponent down. So we get p times log base b of x. So you can bring an exponent down out in front. Or you can take something that's multiplied out in front and put it up as an exponent. It goes both ways. So, for example, I'll show kind of both ways here. If we had natural log of 4 to the x, that's the same thing as x times the natural log of 4. So if I want to take something that's in an exponent and bring it down, I can do that. And that's what's kind of nice with logs in general. So this is something that we're going to be using a lot when we solve equations involving exponentials. If I want to have, or if I want to take something that's in the exponent and bring it down, I can take the natural log of both sides of the equation, and that'll bring my exponent down so that I can work with it and solve for it a little bit easier. So that's going to be something that's really useful for us later. If we're trying to condense things and put it all under one logarithm, then if I had 3 times log of x, I could bring this up into the exponent and have log of x to the 3rd. So it works both ways. I can put something into an exponent, and I can also use this to take something out of an exponent. So that's going to be a really useful property for us now and later on. Okay. So here's what we are going to do with those properties. The first thing we're going to learn to do is combine things. The second thing we're going to learn how to do is a different way of evaluating logarithms. And this different way of evaluating logarithms doesn't necessarily need to replace what we've already done with putting things into calculators or solving using changing the order around into exponential form, but it can. It's another way to think about these things. It's something to kind of help us get more experience manipulating logarithms. So here we go. So this example is going to involve condensing and combining things into one logarithm. Okay, so we're going to combine natural log of 8 plus 5 natural log of x minus natural log of 3 minus 2 natural log of y. Okay. So we're going to condense this down to one logarithm. So the first thing that I want to do here is notice, before I do anything, that these are all natural logs. So they're all logs with the same base. That's important because if they're not logs with the same base, then I can't really do much at all. So they need to have the same base for me to do anything. So that's the first thing that we want to notice. They all have the same base. The second thing that we want to notice is that we've got something multiplied out in front here. In order for me to combine using the product and quotient properties, I first need to use the power property to make this thing not have anything out in front. So the first thing I'm going to do is the power property to get natural log of 8 plus natural log of x to the 5th minus natural log of 3 minus here as well, natural log of y squared. Okay. Then, from here we have a couple things we could do. What I'm going to do is, since I have multiple things subtracted right here, let's see. Yeah, I think that's what I'm going to do. I'm going to factor out a negative out of these two since they're both negative. So I'm going to, so that it makes it a little bit easier for myself down the road. So I'm going to go natural log of 3 plus natural log of y squared here with the negative out in front. Because then I'm going to go ahead and use the product property. So the product property says that if I have things that are added together, I can actually take it all under one log and multiply the things. So we're going to have natural log of 8x to the 5th minus natural log of 3y squared. Lastly, we're going to do the quotient. So then we'll end up with, since I have two things that are subtracted, that means I can divide them underneath one logarithm. So we have 8x to the 5th over 3y squared. And now it's all underneath one logarithm. So we've condensed this thing all the way down. And you could, instead of doing all of this, or instead of doing the factoring out step first, you could go left to right and just start combining things as you go. This way just makes it a little bit cleaner so you don't end up with, if I were to do it the other way, you'd have 8 times x to the 5th, and then you would divide by 3, and then you would divide that by y squared. So you'd end up with multiple steps of division, which you can then combine later to get this exact same thing. I just thought this way was a little bit cleaner, but it doesn't really matter. You could just do it left to right if you would like. All right, so that's one example of how we would condense and combine things into one logarithm. Any questions with that one so far? Any numbers we're not sure where they came from? Anything we're not sure why or how we did it or how we knew to do it? All right. If you do have any questions at any point, feel free to type it in the chat or say something. We're going to do another one. we're going to have 6 natural log of 3 plus 4 natural log of x minus 2 natural log of y. All right. So again, the first thing we want to do is deal with the power property. So I'm taking anything that's out in front and moving it into the exponent to get natural log of 3 to the 6th, natural log of x to the 4th, natural log of y squared. Then we're going to combine things left to right. So first we go here and combine these using the, oops, that's product, not and quotient. Not power and quotient. Product or quotients left to right. So combining these with addition means we're going to be multiplying. So natural log of 3 to the 6th times x to the 4th. 3 to the 6th is also known as 729, so I'm going to actually substitute that there. 3 to the 6th power is 729, x to the 4th. And then we still have this minus natural log of y squared. So we go ahead and combine these using quotient. Natural log of 729 x to the 4th over y squared. And this would be our answer. All right, so we're just combining things left to right after we do the power property. Any questions with that one? Any numbers we're not sure where they came from? Any steps we're not sure why they happened? Or how? Okay, I'm gonna give you guys one to try. We have 2 natural log of 7 minus, let's see, whichever one is first goes on top of the fraction. So if it's this minus this, this goes on top. Good question. All right, there's one for you guys to try. When you think you've got an answer, type pineapples in the chat. Times. Yeah, it'd be 4 times 2. Since it's, yeah, an exponent to an exponent. Cool. All right, Merrick thinks he has it. If that's how you started, you're on the right track. There's another step for you if you're looking to check your work. All right, so if you finished, you should end up with natural log of 49 y to the 8th over x to the 3rd. Over x to the 3rd. All right. And the reason for that being when you go to add these ones, when you're multiplying 49 over x to the 3rd times y to the 8th, that's like multiplying by y to the 8th over 1, if you want to think of it that way. So when you multiply fractions, you multiply straight across, and this is what you get. Okay. So 2 more things that I want to mention for today. The first of these 2 things is just another method of evaluating logs when they're being combined. So evaluating logs. So first of all, we did talk about when you evaluate logs, if it's all of the information is given already, there's no variables or anything, you can just stick it into a calculator. That does work. This is another way that you can do it, especially when you have numbers that work out nicely together. So we have 3 log base 2 of 8 plus 5 log base 2 of 1/2. So the nice thing that we can notice here about these logs is that since it's a log base 2, I'm looking to put whatever is in here in the form of something, some kind of power of 2. And the nice thing is that 8 and 1/2 are both nice powers of 2, because 8 is 2 to the 3rd power, and 1/2 is 2 to the negative 1st power. So if we can notice that right off the bat, that will help us out a lot, because we get 3 log base 2 of 2 to the 3rd plus 5 log base 2 of 2 to the negative 1st. And log base 2 and this 2 here cancel one another out. Log base 2 and this 2 here cancel each other out. So we're left with 3 times 3, because 3 is all that's left of this, plus 5 times negative 1, because negative 1 is all that's left here. And 3 times 3 is 9, 5 times negative 1 is negative 5, and 9 minus 5 is 4. So that's kind of taking what you did in your IXL stuff yesterday and sort of stepping it up a level and combining it into something slightly different. But again, you could also type this entire thing into Desmos if you would like to, or into a regular calculator. So you could go 3 log base 2 of 8 plus 5 log base 2 of 1/2. Oops. 1/2. And it would tell you that it is 4. So one way to do it, type it into the calculator. Other way to do it, practice manipulating logs and using logarithm rules like this. So you have both of those options at your disposal. This method was preferred before we had better calculators that could put in different base logs and things like that. And then the last thing that I'm going to show you is something that was also a preferred technique before we knew, I guess, more about, or before we had better technology for figuring out logs and calculators and things like that. And this is called the change of base formula. The change of base formula. So the logs that typically come on a calculator, like if you've got a TI calculator or whatever, log base 10 and natural log will both be kind of in the buttons on the front of your calculator. Like you don't have to go into any extra settings or anything like that to find those buttons typically. They might be like a secondary function or something like that, but they might not be. But natural log and log base 10 are kind of your standard logarithms. And so a lot of times what we want to, or sometimes anyway, what we might want to do is change our logarithms into that base, into a base 10 or into a natural log. And so to do this, you can use something called the change of base formula. And it helps with evaluating logs sometimes. I mean, now that we can type in log base 2 of 7 or whatever into the calculator, it's a lot less useful of a formula, but it used to be a useful formula, so I'll tell you about it. So here it is. Log base b of x is equal to log of x over log of b. So log base 10 of x over log base 10 of b. Or you could also have it log base of x is equal to natural log of x over natural log of b. B, not x. So you can use this to effectively change it into whatever base you would like. Typically, these are the bases that we would change them into, base 10 or base e. So for example, if I had log base 2 of 7, I could change this into log of 7 over log of 2. And then you would take your calculator if you wanted to finish evaluating this and type in log of 7 divided by log of 2, and then you would get your answer. So what this would look like in a calculator. And you would get this long decimal because log base 2 of 7 is not a nice, easy number. It's like 2.807, bunch of stuff. And that would be your answer. Or you could do natural log of 7 over natural log of 2. Or, honestly, now we can go log base 2 of 7, and you get the same exact thing in the same exact amount of time. Maybe even a little bit quicker, because this was quicker to type than this. But yeah, so any more, the change of base formula is a lot less useful, especially since you're going to be evaluating it in a calculator anyway. But before, the change of base theorem was a nice thing to have. But yeah, so that's change of base formula to help you approximate a logarithm where the value isn't a nice number. So any questions with change of base or with anything that we've done so far? Okay. I'm going to post the homework assignment, and we'll talk about a couple of the problems, you know, what we're supposed to do, what's expected on the assignment. And then if you have questions after that or want to see more examples, you can stick around and we will do as many examples as you'd like. Okay, so today's assignment is a worksheet. The first part of the worksheet, we have one of those evaluate type problems. You can either condense or rewrite the logs first, or you can type it into a calculator. Doesn't really matter to me which one you pick. So this is like that example right here that we did, where you saw that we could type the whole string into the calculator, or we could rewrite the logs as exponents with a base the same as the base of the log, so we can cancel the log and then multiply and all of that. Either way you would like to do that is fine. If you want practice manipulating logs, maybe do it this way. If you would rather just type it into the calculator, though, go for it. These ones, we want to condense the expressions. So bringing the exponent or the number out in front up into the exponent on both of these, and then either multiplying or dividing depending on what's called for here based on addition or subtraction. These ones express each logarithm in terms of natural log of 10 and natural log of 3. Actually, that's not the most useful. Let's see, or is it? No, not really. You don't have to do the first 4 here. That's not the most, those aren't the most useful problems. I didn't read those very clearly. I thought it said to, actually, no, we've got enough evaluating ones down there. That's okay. So yeah, don't do the first 4 here. Unless you want to. If you want the extra practice, that's basically taking, for these ones, taking what we did for evaluating and kind of baby stepping our way into it. So writing something as in terms of natural log of 10 and natural log of 3 would be similar to that. Condense the expressions, more condensing stuff. So again, putting things into the exponent and then making it either a product or a quotient for all of these. These ones evaluate each logarithm. You can either use the change of base or just type it into a calculator. I don't care which way you do it. I would probably recommend just type it into a calculator, honestly. Because using change of base, you end up typing it into a calculator anyway. And then this last one, read through it, give it a try. It is a word problem, but don't let that scare you. Read what the thing says, the variables mean and all of that, and then give it a try. Okay, so that's your homework assignment. Again, you don't have to do these first 4 here. But yeah, if you have questions or you want to see any more examples of anything, or if you want to do a particular problem off of the worksheet with me, then stick around. Otherwise, you are free to get going and work on the assignment. Also, there's a couple of you who have not yet done a couple of your quizzes. So if that is you, please, please, please work on getting those quizzes in. That's going to be the thing that makes the biggest difference at the end of the quarter here. And we're getting close, real close. So please work on those quizzes and getting them turned in.